Hi friends, welcome back. Hope you are doing well. After a short break, we have again rejoining here to discuss about that fourth unit in the embedded systems, embedded based or task based embedded systems. In this one, now we are going to discuss about that next topic as scheduling. There are two types of scheduling. What's the need for scheduling? If you are having so many works to do means what you will do. First we have to divide the work and we have to schedule that one. At what time this work has to be done and what time the next work has to be done. First we have to order the works to be done. Then we have to give timings for doing the work. Okay. So here also the operating system arrange the tasks to be done in a proper manner, and they are giving some schedule as we are doing in our timetable. Okay, we are having timetable for Monday to Friday or Monday to Saturday. We are having 6 days timetable, day order timetable is there, and then we are having per day 7 hours, like that we are having now. So we are scheduling that class hours. Similarly, the operating system also schedule the process what has to be done. Okay, so in this one we are having two types of scheduling. First one preemptive, second one non-preemptive scheduling. Preemptive scheduling means if two or three tasks has to be process has to be done means there will be one of the tasks has to be done first and it should not be disturbed by anyone, means that is called as non-preemptive task. If the task has to be scheduled means that is called as non-preemptive scheduling. It should not be disturbed by any other process. Okay, that is non-preemptive scheduling. In that also so many types are there. Let me discuss that one by one. In preemptive scheduling means if one of the tasks is executing, some other higher priority tasks are coming there to stop the currently executing process, means it will stop the process and the higher priority task will be executed first. Then after the highest priority task completed, the preemptive process will continue its process. This is, that is, if you are doing some work, some of them will disturb you and they ask you to do their work first, means if you are ready to that, that is you are preempted. Okay, so suppose you cannot disturb the currently working process. If they cannot disturb you when you are doing some work, means that is non-preemptive. Okay, we are having first let me start with non-preemptive scheduling. In that non-preemptive scheduling we are having first come first serve. We are giving some orderly based. Now in this one, those who are coming first, that will be given first priority. After the task has been completed, then only the next task has to be executed. Okay, first come will be first serve. See that one. Here we are having an example. In this one, 4 processes are there, A, B, C, D. The process timing is 10 minutes, 10 seconds. Okay, process service time is 10 and turnaround time is 10 and waiting time is 0. So if it is coming first for servicing, means it will be executed first. See that one in the graph, it will be executed first. After it executes, the next task in that waiting list is executed. It may be 1 second process, but it has to wait until the 10-second process completed. Okay, this is first come first serve process. Okay, the advantages of this one is better for long process. It is a simple method. There is no starvation. Disadvantage of this one is convoy effect occurs. Even very small process should wait for its turn to come to utilize the CPU. Short process behind long process results in lower CPU utilization. So the throughput is not emphasized. Suppose if you are having some low process, what is that one? Utilization time, service time is slow, means that can be executed first. Then that long service time process can be executed. So that is the disadvantage of this one. Next one is shortest job first scheduling. So what is the disadvantages we have discussed in that previous one is first come first serve. In that one, the shortest job has to be wait until the longest job completed. Okay, so in this one we have find which is the shortest job among the given set of tasks. Okay, given set of jobs. So that shortest where service time job will be executed first. The next shortest job will be executed next, like that one it will be arranged. See the diagram. Here in this list we are having process A, B, C, D, the same list. 10 service type is 10, 1, 3, 4. Okay, in this one, while you are executing the first task, that is 1 second service time task is executed. See that one in the graph, the first job executed is 1 second job, the next one is 3 second job, next one is 4 second job, finally the 10-second job will be executed. Okay, so the shortest job will be executed first. What's the advantage of this one? It gives superior turnaround time performance to shortest process. Next, because a short job is given immediate preference to a running longer job, so the throughput is high. What may be the disadvantage of that one? Elapsed time must be recorded. It results in additional overhead on the process. So we have to consider what is the processing time of that one. Okay, this will take longer process. Starvation may be possible for the longer process. So the longer processes, though it needs to be completed first, it has to wait. So it will take more time to complete the longest process. Next one we are going to discuss is preemptive scheduling. Already I told you now. Suppose if a job is executed first, if some other higher priority task is in the queue, means it will be executed first before this currently executing process completed. That is preemptive scheduling. Types of preemptive scheduling: priority based scheduling. In this one, each task is given a priority. Okay, so based on their preference, based on their entry time or their execution time, they will be given one priority. So highest priority task will be executed first. If you are having 4 tasks A, B, C, D, the first task will be given, the priority will be given to A, second priority will be given to B, means A will be executed first, then B will be executed. Like that it will be continued. Suppose if you are executing a process C, at that time if A is try to interfere, it want to execute its process, means C will stop its process and A will be executed. After A complete its process, C will reschedule its process. Okay, it will continue its process. So this is preemptive scheduling, priority based preemptive scheduling. What's the advantage of this one is very good response for the highest priority process over non-preemptive version of it. Starvation may be possible for the lowest priority process. Okay. So with that we have completed the types of scheduling, and then preemptive, non-preemptive scheduling, and the types of scheduling in that one. In next class we will discuss about the next topic, that is task communication, inter-task communication. We will discuss that in the next session. Okay, all the best.